We are going to see the overall all kind of experiments what you can get during your board chemistry practicals. And with the beginning, first let us understand what is the pattern of marking scheme. If you have your certified journal of your college where college teacher or principal signature depends on college, that certified journal carries 5 marks and Viva will carry 5 marks. So these are two sections, like 10 marks together, which most of the students get very easily if you have the certified journal with you. Then there is volumetric analysis, the titration, which is compulsory experiment. And this experiment carries 10 marks. Okay. This is going to be checked by the external examiner. There are always two examiners for exam. One is internal of your college and one is external. So volumetric analysis is completely corrected by external examiner. Now there are different combinations suggested by HSC board. So combination number 1 is basic radical mixture. So over here, you are going to get a set of two radicals together mixed. That analysis is for 10 marks. Second possibility is you might get acidic radical mixture for 6 marks and activity of the recyclable material, that is for 4 marks. I am explaining all the practicals over here. You may or may not have done a particular practical. Don't worry about it. If you have not done it, it will not come for your exams. Set 3 is chemical kinetics experiment, which is for 10 marks. Set number 4, you have thermochemistry experiments called enthalpy of dissolution or enthalpy of displacement, which is for 6 marks. Functional group analysis, organic compound, 2 marks. Analysis of carbohydrate or protein, 2 marks. You can see overall each set is for 10 marks always. Set number 6 is you have enthalpy of neutralization for 6 marks. And once again, activity for 4 marks. Now this combination, set number 4, 5 and 6, or even for that matter number 2, depends on college what to make. These are the most standard ones I have shown. Your college might make a different combination. Let us begin with first experiment, volumetric analysis, which is compulsory for all the students. There are two options in your syllabus. One is oxalic acid versus potassium permanganate. Second one is ferrous ammonium sulfate, which is known as Mohr's salt, versus potassium permanganate. Whichever is the experiment, step 1 carries 3 marks, and that is making of standard solution. Everyone has to do this accurately, because if your solution making is wrong, your entire experiment goes wrong. So if you are doing oxalic acid experiment, you need to weigh 1.26 gram oxalic acid. If you are doing ferrous ammonium sulfate, you have to weigh 3.92 gram of ferrous ammonium sulfate. This weighing needs to be very, very accurate, usually done on a paper on a glass dish. We have to now take this amount in the beaker and add water little by little. So let us say 1 or 2 test tubes of water you add, dissolve it, then ensure that it is dissolved, add some more water. Whenever you are doing ferrous ammonium sulfate experiment, half test tube of dilute sulfuric acid is to be added. If you are doing oxalic acid, please do not add sulfuric acid at that time. So sulfuric is to be only used in ferrous ammonium sulfate, not in oxalic acid. Once you have dissolved with around 2 or 3 test tubes of water, we now transfer this solution to a volumetric flask. Using a funnel, you can transfer it. And now we go on adding water by diluting it up to the mark of 100 ml. You can see in the picture I have marked over there. So on the mark over there, you will find a circular white mark. Up to that, you need to add water so that you get 100 ml. Please do not cross the white mark. Don't add excess. There are some students who add excess and then take out that water. That is absolutely incorrect. So be careful when you are adding it. Completely remain focused when you are doing this experiment. This step is you are making the standard solution of either oxalic acid or ferrous ammonium sulfate. Spend little more time on this step so that all rest of the experiment goes smoothly. Let us go to step number 2. Now you have to wash the burette with water first of all. Discard if any solution you find. It happens that you go to the examination and already there is some solution in it. We should always throw it away and wash with water, because that might be some wrong solution or used by someone else. You might go wrong in the readings. Clamp this burette to the stand and now fill small amount of potassium permanganate. Allow it to flow through the delivery tube. Now over here, let me just explain you the terms over here so that you understand the terminology used. You know, this portion here is known as delivery tube. This is called lower delivery tube. And this over here is called the graduated part, where you have the markings. Whenever you are filling over here, there should not be any air bubble. So solution should be from zero marking, going completely till the tube, and even in the lower part. In case there is an air bubble, you should remove it. Now you fill up to the zero mark, as I said here, and your burette becomes ready over here at this point. So this is your second step, making the burette ready. Step number 3, the actual titration. Using a pipette, we take the 10 ml prepared solution in a conical flask. We add 1.5 test tube dilute sulfuric acid as a catalyst. If your reaction is of oxalic acid, you need to heat the solution up to around 60 to 70 degree on a burner. While checking the temperature, you don't have to use a thermometer. You know, when you heat it on the mouth of the conical flask, you will find fumes coming. So the moment fumes are there, that means temperature has reached 60 or 70. In case your titration is with ferrous ammonium sulfate, you have to do the titration at room temperature. You do not have to heat at all. So my first step in titration is I repeat the steps over here. You are taking 10 ml of the solution using a pipette. If titration is of oxalic acid, we heat up to 60 to 70 degree. If it is ferrous ammonium sulfate, we do not heat. We do the titration at room temperature. Now we start taking the reading. We go on adding potassium permanganate from the burette till the color changes to pink color. This is what we call as the pilot reading or the actual reading. Suppose you start from 0 ml on the burette and you go on adding it, let us say till 8 ml, and you get pink color over here at exactly 8 ml. Listen very carefully. Pink color is obtained exactly at 8 ml. So at that condition, we need to write pilot reading. Now what is pilot reading? The range of reading, which will be 7 ml to 8 ml. In case you go from 0 ml and you get your reading pink color at 9 ml, then what should be your pilot reading over here in this case? Pilot reading is going to be 8 ml to 9 ml. So basically, wherever you are getting the pink color reading, 1 ml prior to that is the range. You see, you are not crossing 8 ml, so pilot reading is 7 ml to 8 ml. In case you get, case number 3, in case you get a reading from 0 ml to, let us say, 8.3 ml, No problem. You write the pilot reading as integers only. So it will be 8 ml to 9 ml. So 8.3 also we report pilot reading as 8 to 9. Pilot reading is never reported in fractional numbers. So pilot reading called 7.3 to 8.3 is completely wrong. I hope this concept of pilot reading is clear to everyone. You have to report pilot reading to the teachers in case they are asking it. Now you go for actual reading. And you have to get the same pink color itself. Try to get as light pink color as possible. So what is the way to get a correct pilot reading, to get correct light reading? You see, in step 1, you found out that pilot reading was 8 ml to 9 ml. This was your pilot reading. Now the correct way of getting light color is you add from 0 ml to 7 ml continuously. 1 ml prior I am waiting. And now after this I will add drop wise KMNO4. Literally drop wise. Do not add excess. When you add very small quantity, wherever first light pink color you get, that is your reading. And you will never go wrong if you follow this method. Note the word, very light pink color has to be obtained. More, you have to record 3 such readings. So suppose my reading is 8.3, 8.3, 8.4. Out of the 3 readings, whichever reading has appeared 2 times is called constant burette reading, CBR. So in the column of CBR, we will be reporting reading as 8.3 ml. Let us say my readings are 8.1, 8.3 and 8.2. I cannot report any CBR here because all my 3 readings are different. In that case, you need to really take a 4th reading and see where it matches. Then suppose my 4th reading is 8.3 again. I can change this to 8.3 and my CBR is 8.3 ml. I hope the concept of CBR is understood. It is the reading which happens 2 times similar. Please do not take average of the readings. Please do not take average of the readings. Reading which appears 2 times is called CBR. Now, your major part of the experiment is done. You need to write it in your answer sheet, these readings, and get it signed from your examiner. Once they sign it, only then you can go for the calculations. I am not explaining any calculation here because as per your handbook, you need to take the calculation part. Simply substitute it and you will get your answers in molarity. Final result, molarity of potassium permanganate must be written in the answer sheet before submitting. In volumetric analysis, every step carries marks. So in case you forget to write results, in case you go wrong in calculation, those marks of those steps will be deducted. So please be careful. This is a simple experiment and you can get full marks in it, provided you do it with caution. Let us go to experiment number 2, which is one of the most important but very easy experiment, which is basic radicals analysis. As per our syllabus of Maharashtra Board, mixture will contain 2 radicals, 2 cations. And the good news is one of them has to be NH4+. Basically, we say we are finding 2 radicals, but actually we are finding only 1. Because we know the answer of the second radical right now, it is NH4+. So those who get this experiment, they are very lucky. You have to just find 1 radical for it. The step number 1 is about color. You need to spend half a minute to understand this that color decides the radical. Blue or bluish green sometimes, a shade of green sometimes is possible, is going to be copper plus 2. If it is dark green, then it is nickel. If it is pink, it is Mn plus 2. And if it is white, other than these three, any other radical might be present. So if you get a colored salt, you are extremely lucky. From the color itself, you understand the mixture. You just need to do common sense test and get the result. Nature is always soluble as per our syllabus. There is no insoluble salt in our course. Next, we have dry test. First is called heating in a dry test tube. We need to take a test tube and make it first of all dry. If in the test tube moisture is present, this test will give you wrong results. This is a test where you can get multiple observations. Like you can get crackling noise, you can get white sublimate, and you can get residue. Now use a little bit of common sense here. If the salt given is white, automatically I am going to get white residue. If salt is itself colored, I am going to get a colored residue. White sublimate is indication of ammonium. And we said earlier that ammonium is always going to be present. So I need to decide between whether I'm getting decrepitation, whether I'm getting swelling. White sublimate, always and always I'm going to get. And depending on the color of the salt, I will decide white residue or colored residue. Residue is that thing which is the leftover part after the test is over. So after you finish the test, what is the color of the compound remaining? Is it white? Is it colored? Just need to report that. So you pay attention to the observation, report the observation, write the inference given in front of it as it is without any thinking. Second test you have is called flame test. Now in flame test, you use what is known as a platinum wire. Now there is a very easy trick of doing this test. I'm using it little unofficial method over here. You have a platinum wire, which is a glass tube, and there is a platinum wire over here. So what is my way of doing it is this way. I dip this platinum wire first in concentrated HCl. Number 2, I dip it in the raw salt. And then number 3, heat it in the flame and observe the color of the flame. Whichever color I get, that radical might be present. I repeat, little bit of shortcut or a hack for this test. Number 1, dip the wire in concentrated HCl. Moist wire with HCl, dip it in salt, heat it in a flame and check the color. You are definitely going to get a correct color in this test. Next one, test of ammonium. As you know, ammonium is present in every mixture. This test you are bound to get every time. At this moment, we need to write what is known as the probable radical and get a signature from the examiner. So one of your probable radical is going to be NH4 plus. So when you write this, one radical here is going to be NH4 plus. And suppose my given salt is blue in color, I get suppose bluish green flame that indicates presence of copper. So my second radical is going to be copper plus 2. Let us say my salt is white and I'm getting a flame test which is apple green. Obviously, my radical is going to be Ba plus 2, second value NH4 plus. So looking at the flame test, majority of the time you can get the probable radical. Let us go for next point, preparation of original solution. So now whatever mixture is left over, we add around 3/4 of the test tube water in it. So test tube around 75% you fill with water, add it in the mixture and dissolve it. This solution is called original solution. Now, whichever probable radicals were there, we need to find out whether they are really present or not. So this is called analysis. So we have test number 1 here. Test number 2, Nessler's reagent. You get brown PPT. Just follow your handbook and go on doing the test. Next, we have detection of groups. Those who remember the chapter of practical chemistry, we had done these groups. We had done the theory behind it. So here we have HCl, which is group number 1. HCl, common ion effect, and H2S water, group number 2. NH4Cl, excess of NH4OH, group number 3, and so on. Go on performing this test. Whichever group you get, stop at that point. So suppose my mixture is containing copper plus 2 and NH4 plus. Copper plus 2 will be over here. So I don't have to perform the rest of the test. My analysis gets over here. Once you get that particular test, now next page you go for confirmatory test and perform that radical's confirmatory test. So in case I'm getting copper plus 2, I will perform copper plus 2 confirmatory test. In case I get lead, I will perform that much. So rest of the chart is just blindly to follow whichever tests are left over. I am not discussing each and every test here because it's just blindly you need to follow this book. So the handbook will be in front of you in exam. You do not have to by heart anything. So you follow your college handbook, keep it in front, go on following the test. So there are tests like aluminium confirmatory test, nickel confirmatory test, manganese, and so on, barium, strontium. Whichever is your probable radical, you will get a corresponding test. Finally comes the step of results, where you will report your result as it is. This is your second set of experiments known as basic radicals analysis. Whichever radicals you have done in your college practicals, whichever are written in your fair journal, same thing will come in your board exam. Don't think of anything other than that. Now comes a second experiment number 3, acidic radicals, which is again a simpler and shorter one. Here, the color always is most of the time white. There is no colored salt in acidic. All acidic mixtures are soluble in water. So there is no other option in it. Now here we have dry test. So we only take the given mixture in solid state in a test tube, add the said chemical and check the observation. Let us say if you are getting brisk effervescence, carbonate is present. In case you are getting colorless gas turning red litmus paper white, which is known as a bleaching test, then it might be chloride. If you get dark reddish brown gas, it is bromide. If violet vapors, it is iodide. Little pale brown fumes, it is NO3. So depending on whichever you are getting, you will report probable radicals. As I said earlier, ammonium is always common in basic. There is no such hack over here. They can give you absolutely any combination, right? Let us now come to the last part of this section. We prepare once again original solution and just go on performing the test, confirmatory test. Whichever confirmatory test you will get, that will be your radical. I'm just showing. Please go through it quickly. Last part, we write the result, whichever radicals you are going to get. In case your college has done acidic radical, do the same combinations. Same thing will come in exam. Acidic radical mixture is only for 6 marks. Now let us come to some easier and simpler and very scoring experiments called thermochemistry experiments. First is enthalpy of dissolution. The experiment in this one involves, principle is this way, we take water around 25 ml. In that we add copper sulfate powder, which is weighed 7 gram. And we see if temperature of water initially was T1, after adding copper sulfate, what is the new temperature? Now understand this experiment, the reaction is endothermic. So if your initial temperature is say 25 degrees Celsius, after adding copper sulfate, it will turn out to be 24 degree. There will be a fall in temperature in this case. So remember, this is the only experiment in the course which is endothermic reaction. If you have followed this much, your experiment is very easy. You weigh 7 gram of copper sulfate. You take 25 ml water in a thermodynamic flask. College to college, the flask differs. This is a common variety available. Insert a thermometer in this water. Measure initial temperature. Show this to your teacher and get a signature. Add copper sulfate, whatever you had weighed. Keep always the cover closed. Now shake well, but slowly. Measure the final temperature, which I said it is going to fall down, and get it signed from the teacher. Just substitute this difference in the formula. Experiment is done. One of the most easy experiment you have. Second experiment is enthalpy of neutralization. Once again, I will explain the principle. We take 100 ml HCl. We measure its initial temperature. We take 100 ml NaOH separately in a different flask, measure its initial temperature. Now we mix them and measure final temperature. There will be at least 3 to 4 degrees Celsius rise in the temperature. That is all in the experiment. So process is 100 ml NaOH in the flask. Insert thermometer, make a note of initial temperature, get it signed. 100 ml HCl in another flask. Insert thermometer, measure again initial temperature, get it signed. Now add HCl to finally this particular flask. Mix well, record final temperature, get it signed. Subtract the two temperatures, rise will be 3 to 4 degree as I said. Substitute in the formula and you will get the result. Again, a very simple process. Both these experiments carry 6 marks as I said. Experiment number 3, enthalpy of displacement. This is based on electrochemistry or EMF series principle. We take copper sulfate solution, 25 ml, and measure its initial temperature. We add zinc powder, which is given to you by the college. We mix it very well and check the final temperature. The temperature will be 6 to 8 degree higher than the original one. So if you start with, let us say 30 degrees Celsius, you can get around maximum 38 degree as a rise. So 8 degree rise will be seen. So 50 ml of copper sulfate, it's not 25, 50 ml, same in flask. Measure initial temperature, get it signed, add the zinc powder, immediately close the cover, insert thermometer, measure the final temperature, get it signed from the teacher, substitute the difference and write the result. All these experiments are called physical experiments. We go to organic functional groups. Now you have two things over here. You can either get solid organic compound, you have to find a functional group in it, or you will be given a liquid substance. There are different charts for it. So if it is solid, all these experiments are carried out in test tubes, remember. So we take a small amount in the given test tube, just a little pinch of compound, and carry out the test. So first, if you are adding saturated sodium bicarbonate, and if you get effervescence, it is carboxylic acid present. If you are adding, suppose this test doesn't come, then you have to do the second test. Now take new sample in a fresh test tube, add 20% NaOH. If it becomes soluble, then phenol is present. If not, then obviously third one is present, which is called diazotization test, orange red dye test. This chart is for solid organic compounds. Comparatively easy one is liquid. Procedure is similar. In a test tube, we take let us say 1 ml of a compound and carry out the given tests. Whatever is the test coming, accordingly you will report that particular functional group. Remember one common sense, that every compound has only one functional group. So suppose you get the first one as your answer, don't have to proceed ahead at all, because you got your answer. What are you searching further? So in the result, let us say if you get carboxylic acid, you need to write the spelling over here, carboxylic acid, and then draw the structure of it this way. Kind of this way result you will write. This is about functional group. Only one compound is given to you, which is for merely 2 marks, but it's a scoring experiment. Next is carbohydrates and proteins. You will be given a carbohydrate sample, add 1 ml iodine solution to it. If blue color appears, carbohydrate is present. Second experiment is proteins. Add 1 ml of Milan's reagent to the sample. If white precipitate is obtained, protein is present. Either carbohydrate or protein, it's for 2 marks. Next, I think in the list, the last experiment, chemical kinetics. In case you have done this experiment, you can refer to this. It's that way a long but an easy experiment. What we have to do is we have to take 4 glass conical flasks and take in them sodium thiosulfate, Na2S2O3, as per the amounts given, 20 ml, 30 ml, 40 ml, 48 ml. In this one, you will add the prescribed amount of water. Now, if you observe, total out of all this, we are adding amount 48 ml in each flask. Now, keep a stopwatch ready and add 2 ml of HCl in first flask and count the time when solution becomes milky. Usually this kind of stopwatch is given to you. Now, what do you mean by solution turns milky? How do you record the time? For that, they give you this kind of arrangement. There is a cross mark given to you. And now, let us say you have added 2 ml of HCl over here. Reaction gives you completely milky solution, and this cross mark from above you cannot see. That is the time in seconds you will record. We will plot a graph as per the given thing, concentration on x-axis and 1 upon T on y-axis. You do not have to calculate anything. You do not have to find any slope, nothing. It's very, very easy experiment. Only do up to this much and experiment is done. This is an experiment for 10 marks. This, in case you have done in college, most of the colleges do this experiment. 2 plastic materials will be given to you. And on that plastic material, there are these kind of codes. In case you are having any plastic material with you right now, at the bottom of which this kind of modes are given. These are called recyclable modes. If your number is 1 to 5, that means that plastic is recyclable. If the RIC code is 6 or 7, it is non-recyclable. You just have to report this. That's all. You don't have to think. Don't have to write the name of the polymer also. Like HDP is high density polyethylene. They are not going to ask you this. This is for each plastic material is for 2 marks. Totally, it is 4 marks experiment. I have finished discussing the overall experiments. Let us understand some basic instructions. If your exam begins at 10:30, you have to be outside your laboratory at 10:15. I repeat this, and in case you have slept, I repeat again. In case your exam begins at 10:30, you have to be there outside the lab at 10:15, because they will take you in, they will make you sign your attendance, check your journal, then take a paper and go to your table. This is to be done for all the students in lab. This takes 15-20 minutes, right? So whichever batch, your batch begins at 2 o'clock, ensure that you are there outside the lab 15 minutes prior. This is most important. Exam is at 10:30. I am going to enter at 10:30. You are going to miss out the initial instructions. Carry whatever things I have told over here or whatever your college has told. Listen to the instruction carefully. Just go on following. If you have any doubt in the steps, please ask the teachers over there. Don't ask your neighbors. They do not know anything. So ask your teachers. They will help you. It is board exam. Everyone is there to help you, guide you, and give you marks happily. So absolutely all the best from my side. And